So as we take a look, this is our last section for chapter 10. I wanted to keep this one separate because this is a special situation. All right, so when we take a look, we have our complex numbers, okay? This is what's going to happen when you guys start square rooting negatives. Before we said if we do a square root of a negative, we would get no real solution, okay? And if it's not real, it means it's imaginary, okay? So if I take a look, it says goal number 1, write the square roots of negative numbers in I form and perform operations of numbers in I form, okay? So that's an imaginary form. Goal number 2, we're going to determine the equality of two complex numbers. And goal number 3, we're going to add, subtract, and multiply complex numbers. So as we take a look, the big idea today is I is the square root of -1, okay? So if you ever see something like this, you know that it says, I love math, right? Da-da. Oh, get it? Square root of -1 is I, get it? Well, if I is the square root of -1, then if I square both sides, then I squared is -1, okay? And we'll work on that one in a little bit. So as we take a look, I've got the square root of -36, okay? If I type that in my calculator right now, I'm going to get no real solution, but we want the imaginary solution. So here's the idea, is the square root of -36 is the square root of 36 times the square root of -1, okay? Well, we know what the square root of 36 is, right? What's the square root of 36? Just 6, right? It's got a pair of 6s. And if you want to break those down 2 and 3, 2 and 3, there's pairs of 2s and pairs of 3s, or just pairs of 6s. So that's 6. And then the square root of -1, this guy, is I. So final answer would be 6I. So 6 times I, or 6I. So not too bad. Nothing you can't, if you can do the square root of 36, you can do the square root of -36, just put an I on the back. So as I take a look, I've got the square root of -54. Well, you can do the square root of 54, and now you should know what the square root of -1 is. So as I take a look, the square root of 54, we know breaks down to what? Give me two numbers that multiply. 9 and 6, 3 and 3. And then you can try to break down 6, but 6 doesn't break down nicely to pairs, so I'm going to box that up. So I end up with pair of 3s coming outside. I write that once, and then, the 6 is on the inside. And then what's the square root of -1? I. Just I. So I would write this as 3I root 6. Or you could write it like this, 3 root 6, and then I. Either or. Okay, I prefer this. I think this looks nicer, so 3I root 6. You could also do 3 root 6I. Just know that the I is on the outside of the square root. You guys okay with that? All right, so we take a look at the next one. Again, same idea. This is the square root of 16 over 25, or the square root of 16 over the square root of 25. And then times the square root of -1. So far, so good. All right, so as I take a look, what's the square root of 16? 4. What's the square root of 25? 5. And the square root of -1 is just I. Okay, if you need to, break those down. Those are nice, pretty squared numbers. 16 is 4 squared, and 25 is 5 squared. So 4/5, and then I's for final. So far, so good? Any questions? All right, so when I take a look at the next one, I've got the square root of -48 over the square root of -3. Okay. So one thing I can do is break these down individually. Okay. Or I can look to reduce. The thing is, the one on top has an I in it, and the one on the bottom has an I in it. So I can look at this a couple different ways. Does 48 and 3 reduce each other at all? Is 48 divisible by 3 at all? Calculators? It's not, is it? Or is it? I think it is, isn't it?
I mean, if that's the case, then would you just leave it?
What's
16.
Yeah, it's what is it?
16.
16, that's what I thought. So this is really, and I didn't even touch it and change. Here we go. This is really the square root of 48 negative over the square root of negative 3, which we agree is the square root of positive 16. And what's the square root of 16? That's 4. Now, if you looked at each one of those individually, you would have an I on top and an I on the bottom, and those I's would cancel out. So we don't have any more I's to worry about. So final answer is just 4. And that's because this guy reduces this guy. Is everybody okay with that? All right. So that's the basic idea when we're simplifying. Now we're going to start looking at goal number 3, where we're adding and subtracting these complex numbers, these roots. Okay, so as I take a look, it says perform the operations and then simplify. Hint, need to take the I out first. So as I take a look, I got the square root of negative 9. Well, what's the square root of 9?
3.
What is it? Square root of 9 is just 3. And the square root of negative 1 is I. Well, look at the square root of 49. You know? So that's the square root of 7. Of 49 is 7, and the square root of negative 1 is I. Well, now we just add these two together. So I have 3i plus 7i, which is 10i. And that's it. So it seems very scary at first, but it's not too bad. So again, if you need to, I'm going to take the square root of negative 32. I'm going to break it down. So it's the square root of 32 and the square root of negative 1. And then break down 32. How do you want to break that down? What did you say? 8 and 4? Okay. And then 2 and 4? You can break those 4 downs, but I see a pair. I see a pair of 4s, so I'm going to circle those and write it one time. And then, this little 2, he's left inside. And then what's the square root of negative 1? So I get 4i root 2. Okay. And then over here, I have minus 2 root 2 times a negative, or square root of negative 1. Well, this guy simplifies to negative 2. Square root of negative 1 is I, and then root 2. And we talked about when we're adding and subtracting roots, you're just adding and subtracting the numbers in front of like roots. I have root 2's here. So take the 4i and the negative 2i and combine them. So 4i minus 2i is just 2i and then root 2. Some people like to write it like this, 2 root 2i, like that. Either or is fine by me. I like this way. I think it looks nicer. 2i root 2. So I'll break them down. If it has a square root and it's a negative underneath, just convert that to I. Okay, I'm showing a lot of work here as I'm going, but it's not too bad. All right, so let's flippy flop. Any questions so far, guys? People at home, any questions? Give me a thumb. Where are we at with this stuff? So far, so good. Sideways. Any questions? No? All right, so we got a couple more, and then we'll talk about the power of I. So as we take a look at C, again, we want to get the I out, okay? So as I take a look, I have the square root of 15, that's negative, so break that down. So that's the square root of 15 times the square root of negative 1. So if I simplify that one, that's just I root 15. And I'm going to break this one down. That's the square root of 15 times the square root of negative 1. Well, that is also I root 15. Okay, so I'm going to take this I root 15 times this I root 15. All right, well, first thing is the numbers in front, i's. Take the i's and multiply them together. I times I is I squared. Okay, and now I'm going to take root 15 times root 15. What's root 15 times root 15? Just 15. Okay, now in the front, we talked about what I squared is, so that's the front page. We said that I squared, if I squared both sides, I would get just negative 1. Okay, so again, I squared is negative 1 from the front. So that's negative 1, and then times 15, which is negative 15. So that one's kind of silly. So if anytime you're multiplying two square roots and they're both negative, you're going to get I times I, which is I squared, which is negative 1. You're going to get a negative number, essentially. Okay. Questions so far? So far, so good? All right, let's finish up this one. So we want to look at each one of these. So the first thing I'm going to do is put the I on the outside because this is the square root of 5 times the square root of negative 1. That is I root 5. And then I'm going to multiply that times each one of these. I'm going to take the negative ones. Are you guys okay with me writing it as I root 8 and I root 3? You guys okay with that? So far, so good? So again, the little hint is to take those i's out. Now go ahead and multiply. I'm going to go ahead and multiply here. I times I, numbers on the outside work together. That's I squared. And then 8 times 5 we know is 40. So we get I squared is negative 1. And then 40, what breaks down to what, 8 and 5, 4 and 2. I'm running out of room here. 2 and 2. So we got a pair of 2's here. So sorry, I'm going to have to write in this little box here. So I have a negative 1 times 2. And then I got this 2 and this 5 left inside. I have the square root of 2 times 5 is 10. So that's negative 2 root 10. All right, any questions on that one? So again, I squared is negative 1. 40 breaks down and ends up to be either 4 and 10 and 2 and 2, so 2 root 10, or break it down 8 and 5 and so on. We're going to go ahead and multiply here. So we have I root 5 times I root 3. I times I is I squared. And then root 5 times root 3 is root 15. Again, that breaks down to 5 and 3. There's no pairs. So we can just simplify the I squared. So it's negative 1 root 15, like that, which I would be okay with, or negative 2 root 10 minus root 15. Those are unlike roots. You can't combine them. One's a root 10, one's a root 15. So that would probably be my final answer there. So negative 2 root 10 minus root 15. All right, do you guys have any questions? Well, not terrible. Yes? Yep. You need a tissue?
No, I'm good.
Okay. All right. So as we take a look, we're moving on to the power of I. You'll maybe see a few of these tonight. So as I take a look, I to the first, guys, is just I. And we talked about I squared is negative 1. Okay. Well, I to the third is I times I squared. So I times negative 1 is just negative I. Okay. And now I to the fourth is essentially I squared times I squared, or negative 1 times negative 1, which is 1. Okay. So again, I to the fourth is I squared times I squared. Negative 1 times negative 1 is 1. I to the third is I times I squared, which is negative 1. And that's how I got the negative I. Well, guess what I to the fifth is? What two exponents over here add up to 5? 3 and 2?
Oh.
Multiply these together. What's negative 1 times negative I? What's negative times a negative? Positive, and 1 times I is I. Guess what the next one is? I to the sixth. So if you look at I to the fourth and I squared, that adds up to 6, right? What's negative 1 times 1? Negative 1. I squared is negative 1. I to the fourth is 1. Multiply them together. Negative 1 times 1 is negative 1. Guess what the next one is? Negative I. Guess what the next one is? Do you see a pattern? I, negative 1, negative I, 1. I, negative 1, negative I, 1. Guess what the next one is? What do you think I to the ninth is? I. What do you think I to the 10th is? Negative 1. And so on and so forth. It follows the same pattern over and over and over. I always remember this one is after I won a game, I won with negatives in the middle. Get it? I won, like instead of won the game, but the number 1. I won, but negatives in the middle. So I won, negatives in the middle. Look at that. So if you know these 8, you know these first 4, I won, negatives in the middle, then you can do as many numbers as you want to do. Okay, so as I take a look, I have I to the 8th. So you can do 1, 2, 3, 4, 5, 6, 7, 8, and get 1. Okay. So I to the 22nd, you can go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we'd get negative 1 there. What I usually do is I'll think of, because it repeats after 4, I will think of an exponent that's less than 22 that's divisible by 4. Can you guys think of an exponent that's less than 22 that's divisible by 4 that's really, really close to 22? 20. And then that would be I squared is left. So I to the 20th would put you right here. That would be 1, and I squared is negative 1. So I get negative 1 that way. Or go through and cycle through. I would just go 4, 8, 12, 16, 20, 21, 22. is the idea. Okay? So if I'm doing 43, oh my gosh, I don't want to count 43 times, right? So you can start at the fours, count by fours, 4, 8, 12, dot, 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 or give me a number that's divisible by 4 that's less than 43. 40, and what would be left is the 3. So I to the 40th is 1, and then I cubed up here is negative I. So this is just a little repetitive thing over 4. Every 4, it starts repeating. 1, 2, 3, 4, 1, 2, 3, 4, keeps repeating. So what's 13? What's I to the 13th? That's the same thing as I to the 12th times I to the 1st. I to the 12th just cancels and leaves you with just I to the 1st, or I. All right, do you guys have any questions? All right, so you might see a couple of those. It's always fun to do. Complex numbers. Complex numbers, guys, is basically a number that can be written in this form, a plus bi, where a and b are real numbers. Okay, so we're going to be basically going through addition, subtraction, multiplication, division with complex numbers. So if I take a look, a complex number would be like 5 plus 7i. There's what we call a real part. The 5 is the real part, and then the 7i is the imaginary part. Okay? So as I take a look, they're going to ask us to multiply these guys together. I have negative 6i times 3i. We multiply the negative 6 and the 3 to get negative 18. And I times I, we should know, is I squared. Anytime you have exponents with the i's, you should simplify it. Okay? So if I have negative 18 times I squared, I should know I squared is negative 1. And we multiply those together and we get 18. Okay, so again, do not leave I with exponents. We can always go and simplify those. And we can use the idea that we talked about up here to simplify. We know those will always be simplified to either 1, I, or negative I, or 1. Okay? All right, so when we take a look at the next one, what's this property called again? I can't remember. What's that called? You remember? Greg, you remember what that's called? Starts with a D. Yeah, distribute property. Just distribute the 5. Go ahead and multiply 5. 5 times 4 we know is 20. 5 times negative 6i is what? Negative 30i. That's it. Easy peasy. All right. Any questions? Got a few more I want to talk about before we get out of here today. Oh my gosh. I see something like this. C. We got example 4C. I'm trying to multiply these two complex numbers. The idea is I have 2 terms and 2 terms. 2 times 2 is 4. And there's a 4-letter F word you can say in math class. What we should know is FOIL, first, outers, inners, last. So I'm going to go ahead and multiply. 4 times 2 we know is 8. And 4 times 8i is what? 32i. And I take a look at the next one. I do my inners. Negative 9i times 2 is negative 18i. And negative 9i times 8i is what? Negative 9 times 8, what is that? 72. And I times I is I squared. Well, I can't leave it like this. I need to simplify that. What's negative 72I squared? That's negative 72 times what? What's I squared? Yeah, negative 1. So I simplify that to positive 72. Negative times a negative. Okay? So I combine my like terms. I got 8 plus 72, which is 80. 8 plus 72. And then I combine my i's together. I take 32i and subtract 18i. What's 32 minus 18? How much? 18i? It's less than 18. 16? Less. 14, I think. Unless I'm rusty. Is it 14i? Yeah? And there you go. Final answer, 80 plus 14i. Just talk about D real quick. I don't want to waste our time on easy peasy ones that we just did. When you see a quantity like D, when it's a quantity squared, reminder, write it twice. Write it twice so that you can FOIL it. All right, so write it twice, 3 plus 7i and 3 plus 7i, and then that way you can FOIL. Okay. I want to switch gears. We've done some multiplication. Now I want to get into the conjugate. Okay, we're just going to talk about what is the conjugate. We're not going to multiply them here. All right, so I have 5 plus I. Do you guys remember conjugate? It's been a while. If they just ask what the conjugate is, you rewrite the exact same thing, except if that's a plus, then that's a minus. And that's the conjugate. So the conjugate of this guy, of 6 minus 5i, we're in some technical difficulties. There we go. 6 minus 5i, the conjugate of that one is 6 plus 5i. Okay, just rewrite the exact same numbers that you see, except if there's a minus, make it a plus. If it's a plus, make it a minus. Okay. Get started, we're going to rationalize the denominator for example 6. So yesterday we stopped here, so let's go ahead and finish up. When I take a look at example 6a, I notice that there's really just like one term on the bottom. There's just a 3i. Okay, so anytime there's just one term, the little trick is to get rid of this I. We need to multiply top and bottom by I. Okay, so when we want to rationalize this denominator, we want to get these i's out of the denominator. So what we end up with is 10i on top, and on the bottom, I get 3i times I. Well, that is 3i squared. And from yesterday, you guys remember what I squared is? Yeah, very good. I squared is negative 1, so I'm going to take that, I'm going to plug it in. So I'm going to plug that in right there. So I end up with 10i over 3 times negative 1. Again, I'm showing a lot of work here so you can follow on our notes. So I end up with 10i over negative 3. Okay. So for me, that's okay. I would accept that. If you're plugging this in my math lab and they're being fussy with it, then try this. Make it 10. Put the negative out in front like this, so it's negative 10 over 3, and then put the I outside of the fraction. So it looks like that, negative 10 thirds and then I. Sometimes they want what's called standard form, and that's by writing it like this. Okay, so it's negative 10 thirds and then I on the outside. versus putting the I on top. I'm okay with either one of these, but my math lab, you know how my math lab is. A little
Finicky.
yes, finicky is a good word. I like that word, finicky. Okay. All right, so now when we take a look at the next one, when I'm looking at B, you'll notice B, I have 6 over a binomial. I have this 3 plus 2i. This is where we use this idea of the conjugate, okay? So what we're going to do is we're going to get rid of this I on the bottom by multiplying top and bottom by the conjugate of 3 plus 2i. So first thing is, what's the conjugate of 3 plus 2i? 3 minus 2i. 3 minus 2i. Perfect. So we do that top and bottom. We're multiplying by the conjugate. Okay, we're going to go ahead and distribute the top. So we go ahead and multiply. I'm going to write this down here so I have more room. So 6 times 3 we know is 18. And 6 times negative 2i is negative, what, 12i? You guys okay with that? So far, so good? All right, what do we got to do on this bottom here?
Do the same thing.
We have a binomial times a binomial. What do you have to do? What's 2 times 2? 2 times 2 is what, 4? That 4-letter F word you can say in math class?
Foil.
Foil. We can foil this thing. Now take a look at what happens when you foil this thing. Okay? So I'm going to take 3 times 3. That's 9. Then I'm going to take 3 times negative 2i. That's negative 6i. And I'm going to take 2i times 3. That's positive 6i. And now I'm going to take positive 2i times negative 2i. So 2 times negative 2 is negative 4. And then I times I is I squared. So far, so good? All right. So on top, I have this 18 minus 12i. And on the bottom, I want you to take a look. Look at your outers and inners. I have a negative 6i and a 6i. What's going to happen with those guys?
They cancel.
They are going to cancel. Karate chop those. And now take a look. I have negative 4i squared. Remember over here, I squared is negative 1, right? So this is really negative 4 times negative 1. Well, what's negative 4 times negative 1? Positive 4. Okay, so this completely gets rid of the I on the bottom. And I add these up, I get 9 plus 4. And that's how much? 13. So when you multiply by the conjugate, it completely gets rid of the I value. Okay, again, think of an I as a square root. Math teachers freak out when there's square roots in the bottom. Okay, we're trying to make this nice and pretty. All right, so we have 18 minus 12i over 13. Okay, now for me, I think this looks pretty. My math lab might not like this. Okay, so if you're typing this in and this doesn't look good for my math lab, then what you can do is you can divide both of these guys by 13. So you can write this as 18 over 13, and then minus 12 over 13, and then put an I on the end. Okay, and that's what we call standard form. So we have a real part followed by the imaginary part. Okay, for me, I think this looks much nicer. Okay, but my math lab is, the word is for the day, finicky. So they might require you to rewrite it like this. Okay, and if you can reduce any of the stuff, you can. But in this case, you can't reduce anything, so you just leave it. All right, let's try that one more time, because I know that looks a little scary. Was that scary? So.
It's just the last steps.
Yeah. We had to multiply by the conjugate. We had to distribute the top and FOIL the bottom. Outers and inners canceled, and then this guy in the end will always be a real part. Because again, I squared is -1. We can always get rid of that squared I value.
Hey, it's sunny.
All right. Let's take a look at the last one for today. I got 4 plus 2i, and I have 5 minus i. We need to get this 5 minus i. This is making Mr. Gotsch shake a little bit. Okay? So, sorry, R2D2 is calling me. Sorry about that. So I've got 5 minus i. We need the conjugate of 5 minus i. What's the conjugate of 5 minus i? 5 plus i. So I'm going to multiply by the conjugate of 5 plus i, top and bottom. Okay. Now on top, I have 4 plus 2i. So I have a binomial and another binomial. So if I have a binomial times a binomial, that means I got to FOIL. All right, I'll do the top in purple again. Okay, so I'm going to take 4 times 5. We know is what, 20? I got 4 times I is 4i. So far, so good. I'm going to take this 2i times 5. That's what, 10i. And then last but not least, I got 2i times I. That's 2i squared. Do you remember what I squared is? That's -1. So I always just rewrite this to be -1 times 2 is -2. We okay with that? So I'm going to combine my like terms now. So I have 20 minus this 2. Is everybody okay with how I got -2 here? This is 2 times I squared. I squared is again -1. So it's just -2 really in disguise. So 20 minus 2 is 18. And then I have 4i and 10i. That's what, 14i? So far, so good? Any questions on how I got 18 plus 14i? All right. Last thing we got to do, FOIL the bottom. I'll do the bottom in pink now, pretty pink. We got 5 times 5, 25. Now, usually when I'm doing this, I know the outers and inners are going to cancel, so I never write them, but I'll do it for our notes here. So 5 times I is 5i. And then when I do my inners, -i times 5 is a -5i. So again, those are going to cancel. And then last but not least, I get -i times I. So a negative times a positive is a negative. And then I times I is I squared. Okay. I always change that though. I know I squared is -1, right? Up here is -1. So this is the opposite of -1, which is, yeah. So I always change that to +1 in that case. Okay, so again, outers and inners are canceling. And now I have my real parts are only thing left. I've gotten rid of those i's. I've got 25 plus 1 is 26. Okay, now, for me, I would want you to reduce these. Okay, so if you do it that way, you would reduce everything by 2. I'm thinking my math lab is going to want you to rewrite these like this. Okay, so it's 18 over 26 plus 14 over 26i. And then we can reduce those by 2, right? So 18 over 26 reduces to what, 9/13? Is that right? And reduce these guys by 2. So we get what, 7/13 I? Okay. And again, all I'm doing is I'm reducing these fractions. If you're you're not good with fractions, again, you can always just throw that in the calc and then math frac it. 18 divided by 26, press enter as a decimal, math frac converts it for you. All I'm doing is reducing by 2.